In the vast expanse of our solar system, each planet tells its own story of creation, evolution, and survival. Among these worlds, Mercury stands as a celestial body of striking extremes, one that has fascinated scientists for centuries. Known as the closest planet to the Sun, Mercury is a blazing hot enigma that holds secrets only recently unveiled through space exploration. From its immense temperature shifts to hidden layers of diamond and mysterious glaciers, Mercury's story continues to unfold, revealing surprises at every turn. For generations, Mercury remained one of the least studied planets. Its proximity to the Sun meant that observing it from Earth was nearly impossible. The Sun's powerful light rendered Mercury invisible in most telescopes, and its intense solar radiation posed challenges for spacecraft missions. Early astronomers could only observe fleeting glimpses of the planet during specific times of the year, and even then, understanding its surface and composition was a mystery. It wasn't until NASA's Mariner 10 mission in 1974 that humanity had its first close-up look at Mercury. Mariner 10 managed 3 flybys, capturing more than 4,000 images of Mercury's barren, cratered surface. Despite these efforts, only about 45% of the planet was imaged, leaving much of it still unexplored. Nearly 4 decades later, NASA's MESSENGER, Mercury's surface, space environment, geochemistry, and ranging mission entered Mercury's orbit in 2011, marking the first time scientists could conduct a detailed and sustained study of the planet. Over 4 years, MESSENGER revealed extraordinary findings, from water ice deposits to unique surface features that pointed to a planet of surprising complexity. Mercury's close proximity to the Sun subjects it to some of the most extreme temperatures in the solar system. During the day, surface temperatures soar to a blistering 430 degrees Celsius (806 degrees Fahrenheit), hot enough to melt lead. But as soon as night falls, temperatures plummet to a bone-chilling -170 degrees Celsius (-274 degrees Fahrenheit). This drastic fluctuation occurs because Mercury has no significant atmosphere to trap heat, causing a rapid temperature drop as the Sun disappears from view. Mercury's rotation also contributes to these extremes. With a unique orbital pattern known as spin-orbit resonance, Mercury completes 3 rotations on its axis for every 2 orbits around the Sun. This means that a single day on Mercury, from sunrise to sunrise, lasts approximately 176 Earth days. Its orbit itself is highly elliptical, bringing it as close as 46 million kilometers, 29 million miles, and as far as 70 million kilometers, 43 million miles, from the Sun. Such a combination of extreme solar exposure, fast orbital speed, and slow rotation makes Mercury a world unlike any other. Mercury might appear moon-like with its dark, heavily cratered surface, but its interior is vastly different from Earth's moon. One of Mercury's most intriguing characteristics is its disproportionately large core, which makes up about 84% of the planet's diameter, or approximately 4,100 kilometers, 2,547 miles, wide. This core, which is believed to be composed primarily of iron and nickel, is so large that if it were isolated, it would be bigger than Earth's moon. The planet's surface, on the other hand, is largely composed of rough, porous rock, which gives Mercury its dark and muted appearance. Mercury's albedo, or reflectivity, is only about 6%, meaning it reflects very little sunlight compared to Earth. This darkened surface is likely due to high concentrations of carbon in the form of graphite, which also explains its low reflectivity and unique composition. One of the most remarkable revelations about Mercury involves the potential for a vast layer of diamonds beneath its surface. Recent research suggests that Mercury's crust could contain a high concentration of carbon, present in the form of graphite. Over time, and under the extreme pressures found at great depths, this graphite may have transformed into diamond. Scientists estimate that this diamond layer could be up to 18 kilometers, 11 miles, thick, forming a hidden jewel box beneath Mercury's rugged crust. But why is there so much carbon on Mercury? Experts believe that in its early history, Mercury, like Earth, was covered by a molten magma ocean. As the planet cooled, carbon in the form of graphite likely floated to the surface, forming Mercury's primordial crust. Over billions of years, the intense pressures and temperatures within Mercury's mantle may have caused the graphite to convert into diamond. This phenomenon is similar to how diamonds are formed on Earth, but on Mercury, the process may have occurred on a planetary scale. While this diamond-rich layer is buried more than 600 kilometers, 373 miles, below the surface, scientists speculate that some diamonds could have been brought closer to the crust by ancient volcanic activity or significant meteor impacts. If such diamonds exist near the surface, they might one day provide tangible evidence of Mercury's sparkling secret. Mercury's proximity to the Sun makes it seem unlikely that it could have any form of ice, yet messenger data revealed surprising evidence of water ice near the planet's poles. Within permanently shadowed craters at Mercury's North Pole, where sunlight never reaches, temperatures are low enough to allow ice to remain frozen. These icy deposits are shielded from the sun's scorching rays by the planet's unique topography, preserving them despite the extreme conditions just outside the shadows. In addition to water ice, researchers have found evidence of what they call salt glaciers. These formations are not glaciers in the typical sense but consist of volatile compounds such as water, carbon dioxide, and nitrogen trapped within layers of salt beneath Mercury's surface. Over billions of years, these compounds have remained stable in subsurface salt flows, creating formations similar to the salty niches found in Earth's most extreme environments, like the Atacama Desert in Chile. Some scientists believe that these salt glaciers might even provide habitable environments for microbial life, drawing comparisons to Earth's most inhospitable yet life-sustaining regions. The discovery of salt glaciers raises intriguing questions about the possibility of life on Mercury. Although the planet's surface is harsh and uninhabitable, conditions below ground may tell a different story. Salt compounds have been shown to create stable environments where liquid water could exist at much lower temperatures. This phenomenon occurs on Earth in salt-enriched microhabitats, which can support microbial life even in extreme climates. While life on Mercury remains purely speculative, the discovery of these salt glaciers has implications for the search for life elsewhere in the solar system and beyond. Exoplanets with similar characteristics to Mercury could have subsurface environments that support life, offering a new perspective on the potential for habitability in seemingly inhospitable worlds. Mercury has only been visited by 2 missions so far, Mariner 10 in the 1970s and Messenger from 2011 to 2015. However, the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA, have launched a joint mission to continue our exploration of this enigmatic planet. Named BepiColombo, this mission began its journey to Mercury in October 2018 and is expected to enter orbit in 2025. BepiColombo is equipped with advanced instruments designed to probe Mercury's surface composition, magnetic field, and exosphere. Although it will not land on Mercury's surface, BepiColombo will provide scientists with unprecedented data, allowing them to analyze Mercury's geological history, magnetic anomalies, and temperature patterns. The mission aims to build on Messenger's findings, further investigating the possibility of water ice, salt glaciers, and the planet's unusual magnetic field, which could shed light on its large iron core. Despite its small size, Mercury is a planet of contradictions and extremes. It is both one of the hottest and coldest worlds in our solar system, with blazing days and frigid nights. It is the closest planet to the Sun yet harbors ice in shadowed craters. Its surface resembles Earth's moon, yet its core and inner composition are closer to that of our geologically active planet. As our understanding of Mercury grows, so too does our appreciation for its complexity. The possibility of a diamond-rich interior, the discovery of salt glaciers, and the potential for habitable zones beneath its surface challenge our assumptions about planetary formation and habitability. Mercury's story reminds us that even in the harshest environments, nature finds a way to surprise us. With BepiColombo set to arrive in the coming years, we stand on the brink of yet another chapter in Mercury's story, a chapter that promises to deepen our understanding of this fiery, mysterious world and perhaps offer clues about similar planets scattered throughout the universe. Mercury, the innermost planet of our solar system, has captivated humanity for centuries. As the smallest and densest of the 8 primary planets, this elusive world defies expectations, proving to be far more complex than its barren, cratered surface might suggest. Mercury's extremes, searing daytime heat, frigid nighttime cold, possible diamond deposits, and hidden salt glaciers, reveal it to be one of the most dynamic and intriguing planets in our solar system. Thank you for joining us on this journey into the mysteries of Mercury and beyond. If you love exploring the cosmos, from planets shrouded in mystery to the frontiers of space science, be sure to subscribe to Space Lab. Here, we uncover the secrets of the universe, one discovery at a time. Don't miss out, hit the bell icon so you're always in orbit with our latest updates. Stay curious, keep exploring, and we'll see you in the next episode of Space Lab.